let's go to page 794. This is lesson 12.1, and this lesson is to explore solids. Solid is like a three-dimensional object. So over here it says a polyhedron is a solid is bounded by polygons. So a polyhedron means every face must be made out of polygons. And each of these polygons is called a face. Okay? And that encloses a single region space. An edge of the polygon is a line segment formed by intersection of two faces. Okay, so face is like an area, and the edge is like where the two faces meet. Okay, so this would be example of an edge. Okay. And the vertex is at the corner. Okay, so over here, a vertex of a polyhedron is a point where three or more edges meet. So edges meet in a corner called vertex. So again, so this is the vertex, this is the edge, and this is a face. Okay. So basically think of like dimension. So face is two-dimensional, and the edge has one dimension, which is the length, and vertex is a point, so have no dimension, zero dimension. Okay. And it says the plural of the polyhedron is polyhedra or polyhedrons. So most of the time we just use polyhedrons. Okay, so here's a key concept. So type of solids. Okay, so polyhedra. Okay, so this is a prism. So the base is like a rectangle, and all the faces are parallel. So when you have the base and everything just goes straight up, it's a prism. A pyramid is when you have the polygon as a base, and all the faces converge and connect at one point. Okay, so that's the difference between the prism and a pyramid. So prism, everything is all straight up, and the pyramid, the edges go to meet at one, so have pointy top. Okay. Now these are not polyhedrons, because remember polyhedron, the key is polygons. Okay, so all the face have to be a polygon. So this one, the face is a circle, so it's not a polygon. This one, the base is a circle, so it's not a polygon. Over here, it's a sphere, so it's not made of polygons. Okay, classify solids. Of 5 solids above, the prism and the pyramid are polyhedron. To name a prism or pyramid, use the shape of the base. Okay, so again, the base with the one you're going to use to name it. Okay, so look over here. So this is a pentagonal prism. Okay. And because the base is a pentagon, see the base is a pentagon, okay. So that's the first word came from pentagon, based on the base, and it goes straight up, so it's a prism, okay. Now if it's going to have pointed top, then it's a pyramid. So it says the base is a triangle, so this is triangular pyramid. Again, the first word describes the base. The second word describes the shape. Okay, if it's a prism, means it goes straight up. If the pyramid, it goes to a point. Okay. Okay. So over here, it says the two bases of the prism are congruent polygons. Okay. So over here, the two bases of a prism are congruent polygons in parallel planes. Again, they are congruent and parallel. Everything goes straight up. Okay. Over here, the base of a pyramid is a polygon, but again, it goes to a single point on the top. So make sure you know the difference between prism and the pyramid. Okay. Okay, now let's go to example 1 on page 795. Example 1, it says identify and name polyhedron. Okay, tell whether the solid is polyhedron. If it is, name the polyhedron and find the number of faces, vertices, and edges. So A, okay, so every face is a polygon, so yes, this is a polyhedron. Okay, so make sure you answer the question. So first, name the polyhedron. So yes, so this is this over here. So this is a rectangular, because the base is a rectangle, so it's rectangular prism. Okay, and find the number of faces. So these are 6 faces, so you can just count them. Okay. So the bottom, the top, the front, the back, the right, and the left. So I have 6 faces. Now vertices, okay, vertices are corners. So you got 4 corners up here, corners down here, so there are 8 vertices or 4 corners. And edges. So there are 4 edges on the top, 4 edges on the side, 4 edges on the bottom, so there are 12 edges. Okay. Now let's go to B. Okay, so B, again, every face is a polygon, so yes, it's a polyhedron. So now you have to name it. Okay, remember the name is, you use a base as your first word. So this is a hexagon, right? The bottom 1, 2, 3, 4, 5, 6. So this is a hexagon. So this would be hexagonal pyramid because it goes to the single point. Okay, so hexagonal pyramid, that's a name. Now find the number of faces. So since there's a hexagonal, so there are 6 faces, 6 triangles on the side, plus 1 on the base. So this has 7 faces. Okay, so I have 7 faces. Now the edge. So again, there are 6 edges. There are 6 edges on the side, and there are 6 edges on the bottom. So there are a total of 12 edges. Okay. Now let's go to C. So C, this you have a curved surface, so it's not a polyhedron. Okay, so this is not. Okay, now let's go to the bottom of page 795. Okay, so here, Euler's theorem. Notice example 1, the sum of the number of faces and vertices of a polyhedron is 2 more than number of edges. This suggests the following theorem proved by Swiss mathematician Leonhard Euler, okay, who lived from 1707 to 1783. So theorem 12.1, the Euler's theorem, the number of faces F, vertices F, and the edges E of the polyhedron are related by the formula F plus V equal to E plus 2. Okay, so over here I give the example of a cube. So I have 6 faces and have 8 vertices and have 12 edges. So 6 plus 8 equal to 12 plus 2. So this is a formula, very important formula, make sure you know it. So you can F plus V equal to E plus 2. Okay. Okay, now let's go to example 2. Okay, example 2, it says use Euler's theorem in a real world situation. House construction, find the number of edges on the frame of the house. Solution. The frame has 1 face as its foundation, so that's the bottom, and 4 that makes up the wall, okay, and 2 that make up its roof, the total of 7 faces. To find the number of vertices, notice there are 5 vertices around each pentagonal wall. So each of this wall, okay, is a pentagon, and there are no other vertices. So the frame of the house have 10 vertices. Okay, so you can count the corner, right? So you count it. So there are 10 vertices. So use Euler's theorem to find number of edges. So F plus V equal to E plus 2. You substitute there are 7 faces and 10 vertices. Okay, and so you got 17 equal to E plus 2. So E equal to 15. So there's 15 edges. Okay. Okay, now let's go to the next item. Regular polyhedron. A polyhedron is regular if all its faces are congruent regular polygons. A polyhedron is convex if any 2 points on its surface can be connected by a segment that lie entirely inside or on a polyhedron. If this segment goes outside of the polyhedron, then the polyhedron is a convex. It's non-convex or concave. Okay, so this is convex, and this is concave. The way to remember is think about the word cave. Think about the easy way to remember is think about this got cave in. Okay, so like this is cave in. So this is concave. Okay, think about the word cave in. Okay, so basically convex means there's no dent, nothing get pushed in. Okay, if anything get dent in or cave in, it's a concave. Okay, again, use the word cave to help you to memorize it. Okay. And again, the word regular means every face are congruent. Okay, so this is not regular because the faces are not congruent. Okay, now it says there are 5 regular polyhedra called Platonic solids after the Greek philosopher Plato. Okay, and lives around 427 BC to 347 BC. The 5 Platonic solids are shown. Okay, so this one, a regular tetrahedron. Okay, so you got 4 triangles and you make into a solid, so it's 4 faces. The next one is a cube. The cube has 6 faces. Okay, again, all faces are congruent. The next one is regular octahedron. So you got 8 faces, 8 triangles, made out of the 8 triangles. Okay, 8 faces. The next one is a regular dodecahedron. Okay, do means 2, deca means 12, 10. So 2 and 10 give you 12. Okay, so dodecahedron. Okay, so it means 12. Okay, and this one we did already, right? So regular icosahedron. Okay, regular icosahedron is 20 faces. It made out of 20 triangles, equilateral triangles. Right? It says there are only 5 regular polyhedra because the sum of the measure of the angle that meet at the vertex of a convex polyhedron must be less than 360. So it means, see over here, so every corner, this had to be less than 360. Okay? That means the only possible combination of regular polygons at a vertex that will form a polyhedron. Polyhedrons are 3, 4, or 5 triangles. Okay? Because if you have 2 triangles, then you just have something that looks like pancake. Then you don't have a solid. Okay? If you have 2 triangles, so 3 triangles meet at vertex. Okay? So again, this one, every vertex has 3 triangles. Okay? And this one, every vertex has 4 triangles. Okay? Every vertex has 4 triangles. This one, every vertex has 5 triangles. Okay? But if you try to 6, it will become flat. Okay? Then you were not able to have a solid. Okay? And for the squares, okay, so this one, so you can use a triangle, you can use a square, then use a pentagon. Okay? And that's it. You cannot use other shape to form a regular solid. Okay. Okay, now let's go to example 3. Use Euler's theorem with Platonic solids. Find the number of faces, vertices, and edges of the regular octahedron. Check your answer with Euler's theorem. So here's your the octahedron. Okay? So there are 8 faces, so that's 8. And the vertices, again, you can count it, so that's 1, 2, 3, 4, 5. So 1, 4, and 1 give you 6 edges, right? 6 vertices. So again, 1 vertex and 4 corners and 1 down here. So that's 6 vertices. Now the edges, so there are 4 on here and 4 right in the middle and 4 down here, so that's 12. And you can check. So 8 plus 6 equal to 12 plus 2. So check. Okay. Okay. Now next, let's talk about cross sections. Okay. Imagine plane slicing through a solid. So you have a pyramid and you slice it through. Okay. The intersection of the plane and the solid is called a cross section. So cross section is when you slice through a solid. Okay. For example, the diagram shows that an intersection of a plane and a triangular pyramid is a triangle. So again, if you have a pyramid, you slice through, what you get is a triangle here. Okay. Okay, example 4. Describe cross section. Describe the shape formed by intersection of the plane and the cube. So you have a cube and you slice through, and what you're going to get is going to get a square. Okay. Okay. Again, you have a cube, and you slice through, you're going to get a square. Now, for B, again, if you have cube, but if you slice through diagonally, okay, then what you're going to do is that this edge and this edge are not going to be the same. So what you're going to have is a rectangle. Okay. Now this over here, if you just kind of slice through a kind of a strange, kind of unusual angle, and what you're going to get is a trapezoid. Okay, because you got this edge and this edge are not the same. Okay, so you're going to get trapezoid.